Hey guys, happy Monday. Go ahead and open up your iPads. Pull up the homework assignment from the weekend, which should be the Chapter 4 activity sheet. It should look like this, and we're going to start right up with the true-false. The Earth's diameter is longer through the poles than through the equator. That's definitely going to be false. Earth's magnetic field extends several thousands of kilometers into space. Guys, this is definitely true. Anytime you guys see the pictures of the Earth with the magnetic field, you can see that it really radiates out away, and that's there again to protect us from the solar wind. Earth's axis of rotation passes through the north and south poles. That's definitely going to be true. One complete rotation of Earth requires a little more than 24 hours. See right here it says a little more. This is definitely false. One complete rotation actually takes 23 hours, 56 minutes, and 4 seconds. A swinging pendulum appears to change direction because of Earth's revolution. Look here, revolution, that makes it false. Earth's speed of rotation is greatest at the equator. Guys, that's true. Remember that if you're at the equator, you have a greater distance that you need to cover. Up at the poles, you can stand there all day, and you're not really moving that much, right? Remember when I just kind of pivot in class? Pivot, pivot. Kind of boring, I know. All right, let's keep going. Earth has seasons because its orbit around the sun is elliptical. Guys, this is false. We should all know at this point that we have seasons because the Earth has an axis that is tilted, right, 23.5 degrees, all right, not because of the elliptical orbit. Earth travels about 150 million kilometers during one revolution. Guys, this is false. 150 million kilometers is the average distance of the Earth to the sun, so just think about it. If it went in an elliptical path all the way around, it's got a lot further to travel. All right, that number, though, we're not going to worry about. Earth revolves around the sun at a constant speed. Guys, this is going to be false. If you recall, Kepler said that there are these 3 laws of planetary motion. One of them actually says that as a planet moves through its orbit, when it's closer to the object, it actually speeds up, and then when it extends out, it slows down. Next, Earth's axis is tilted 23.5 degrees relative to a line drawn perpendicular to the equator. Perpendicular, right? Coming upward, that's going to be true. Alright, I'm going to adjust the screen. Stand by. Alright, so now we're up to answering some questions based on the reading passage above. I highly recommend that you guys look through that reading passage. It really makes a nice, clear picture of things that you guys should understand. So, I'm going to describe the answers. You guys can kind of check over your notes as you go. Define and describe Earth's rotation and revolution. So, first let's define it, right? Earth's rotation, that's an object spinning about its axis, so the Earth spinning around its axis. Revolution is an object that's moving about another object, so the Earth will revolve or will orbit around the sun. Now, speaking of rotation, why did Foucault conclude that Earth rotates? Very simply, guys, he set up his pendulum. The pendulum swung back and forth, back and forth. It was at a constant rate. Below it, the Earth was actually rotating, which made the pendulum appear to change direction. If you guys are still confused on this concept, go back and reread the passage, or, as always, go and check out a YouTube video on Foucault's pendulum and his explanation for Earth's rotation. Now, a great question, why does a day last slightly longer than it takes Earth to make one complete rotation? The Earth will rotate 360 degrees in 23 hours, 56 minutes, and 4 seconds. However, it takes just about 4 minutes or one more degree of rotation for it to line back up with the sun, remember that the Earth is revolving or orbiting around the sun. So in order for high noon to line up each day, it takes an actual 24 hours. Very good. And lastly, compare and contrast Earth's perihelion and aphelion. So let's remember that perihelion, near, aphelion or aphelion, far. So basically, when Earth goes through its revolution, there's going to be a point at which it's closest to the sun and a point when it is farthest away from the sun. And we know that this is actually going to be one of those counterintuitive sequences because we think in the northern hemisphere that the summer means that we're closest to the sun, but actually we are closest to the sun in January and we are farthest from the sun in July. Good. Let me change up pages and we'll continue. Earth is similar to the other inner planets in the solar system in its D, all of the above, right? The size, shape, composition. Remember, you want to compare this to the outer planets. When a ship sails away from shore, people watching the shore see the bottom of the ship disappear first. This is because the surface of the Earth is curved. Guys, remember, this wasn't Columbus's wisdom, right? We've known for centuries that the Earth was curved or round. The Earth's magnetic field resembles the magnetic field of a bar magnet. Earth's magnetic field, A, extends far out into space. B doesn't work, guys, because solar radiation, that's how we get our sunlight. However, if it said solar wind, that would have been an option. Earth is farthest from the sun during A, summer in the northern hemisphere. Compared with Earth when it is at its aphelion, when the planet is at its perihelion, D, it is closer to the sun, right? Peri means near, and moves more quickly around the sun, right? That goes back to Kepler. Earth has seasons because of C, the angle at which its axis tilts. Guys, you gotta know that. Got to know that. Let's keep going. I'm gonna adjust the page. Stand by. Alright, and a little definitions. Place in Earth's orbit where it is farthest from the sun. F, aphelion. Spinning of an object about an axis. E, rotation. Imaginary line through Earth between the poles. G, axis. Half of a sphere, such as Earth. A, hemisphere. Movement of an object in an orbit around another object. That is revolution. C. Place in Earth's orbit where it is closest to the sun. That's D, perihelion. Shape of Earth's orbit. Guys, that's ellipse. B. And at the bottom of the screen, or bottom of the board for you guys, Earth has a magnetic field because of convection of molten metals in its outer core. In 1851, the French scientist Foucault observed a swinging pendulum. Alright, I can't actually fit it in so you guys know what I mean. And concluded that the Earth rotates. Earth rotates less quickly at its poles than it does at its equator. The amount of time it takes Earth to revolve around the sun is the definition of revolution. I'm shorthanding, sorry. During summer in the southern hemisphere, the axis tilts toward the sun. That's why right now they're going into the summer months. The exact shape of Earth is not a perfect sphere, but an oblate, I'll spell this one out, spheroid. Makes sense? Good. Earth is one of the inner planets. Also, guys, terrestrial would work here if you're high speed. Terrestrial planets of our solar system. Alright, allow me to fix the pages. On to critical writing. One of my favorite questions. Explain 2 ways that people knew Earth was spherical long before they could observe the shape of Earth from space. Guys, we watched that video on all the different things. So remember the 3 right angle triangle? Thought that was a pretty cool one. The fact that the ship's on the horizon. Yeah, this is not working out so well, so I'm going to stop scribbling. The other examples you guys can go back and review in the reading. Those are 2 that I think are really important. On to true false. Astronauts first walked on the moon in 1969. That's definitely going to be true. The moon is about 1/3 the size of Earth. That's false, right? It's actually 1/4 of the size. The same side of the moon always faces Earth. This is true. The far side of the moon has a thinner crust and more Maria. That is definitely going to be false. Guys, you can actually check the figure in the reading, and the little caption underneath specifically says that most of the Maria, right, about 16% of the moon is Maria, and most of that's on our side. The moon gives off no light of its own. This is definitely true. It's just reflecting light from the sun. Far side of the moon has been seen only by spacecraft. That's definitely true. Moon surface temperature is always very low. That's actually going to be false. Guys, remember that the part that's facing the sun is going to be warming up, and then the coldest parts could actually be deep inside some of the craters that are on the moon. Alright. Volcanic activity ceased on the moon more than 1 billion years ago. That's true. The moon has several high mountain ranges. True, right? That's going to get into that term that we call Torea. There is evidence of ancient life on the moon. That's false. Let's adjust. Guys, I would definitely, again, read these paragraphs. That's why I left them in. And let's just go over these questions. Explain why surface temperatures on the moon vary from extremely hot to extremely cold. Okay, extremely hot because there's no atmosphere to slow down the radiation that's coming in. So that surface is just going to be absorbing and going to be bombarded with energy. And then extremely cold because remember that its rotation is going to take 27 1/3 day. So that means that for almost 2 weeks, there's a portion of the moon that's not getting any sunlight. So you're going to be able to get these really, really cold temperatures. Why is the landscape of the moon unchanging? Okay, if you read up here in the paragraph, it specifically says that the surface is not going to be changing because there's no weathering, there's no rain, there's no winds to be breaking down the surface. Okay, and there's also no plate tectonics to make new surface. Compare and contrast Maria and Terea on the moon's surface. Include how each type feature formed. So the Maria we know is going to be basaltic. Right, I'm going to add a couple little notes here, right? This is going to be basaltic. It's going to be dark. It's going to be smooth, right? Because this is from lava flow, right? That was all from Maria. The Terea, right, we're going to just put over here. Guys, this is going to be the rough It's going to be mountainous, right? So be thinking mountains. It's going to be lighter in color. This is what's going to make up a lot of the surface. It's giving it that aluminum silvery color that I was talking about. Sometimes they also use that word lunar highlands, right? It's an interchangeable term. Where and in what state is water found on the moon? It's certainly going to be found in the frozen form, right? So let's call it ice, right? And if you guys read right up here, there's your answer. All right, I'm just moving right on because we got things to do. Next page. Area on the moon called Maria. This is going to be consists of basaltic lava. The surface of the moon includes craters, mountains. So let's go with D. The moon's core contains little iron. Contains little iron. The mantle of the moon. I'm going to go with D, all of the above. Right? If you're confused on that, go back and check the reading. But you definitely have 2 layers. You definitely have olivine. And it may have high levels of iron. Moon's crust is rich in the element D, all of the above. For the moon to make one complete rotation takes about D, none of the above, because it's actually 27.3 days. The moon has no atmosphere or plate tectonics, D. And adjusting upward, let's run through some definitions, shall we? Dark-colored flat area on the surface of the moon, Maria, E. Relating to the moon, D, lunar. Moon's innermost layer, F, core, innermost. Amount of time it takes for the moon to make one complete revolution, A, orbital, period. Ball-shaped depression caused by meteorite impact, C, crater. Right? Meteorite impacts equal craters. Just throw that in the back of your head. Good. Light-colored highland areas on the surface of the moon, that is Terrea. The moon's outermost layer, crust. Too easy. Let's keep going. Earth's only natural satellite is the moon, capital M. The moon orbits Earth because of the force of gravity. The moon is less dense than Earth. Earth's gravity is 6 times greater than the moon's gravity. Guys, remember that's why you would weigh 1/6 of what you weigh on Earth on the moon. Great weight loss program, I know. The moon's orbital period is 27.3 days. We can see the moon from Earth only because it reflects light from the sun. Features on the moon's surface do not wear down because the moon has no atmosphere. Right, that didn't work. Oh well. Next page. And on to the critical writing. The footprints of astronauts in dust on the moon will remain undisturbed as long as the moon exists unless they are struck by a meteorite. Explain why. Guys, again, no atmosphere, which means no weathering, which means nothing to erase it. Alright, it's not like Earth. It's not like the rain's going to come along and just wash it away. Those footprints are still there. They will be there for a very long time. Alright, Now, more true false. The sun is divided into definite internal layers. We're going to go with true. The hottest part of the sun has a temperature of about 27 million degrees Celsius. We're going to go with true on that. However, the textbook has a typo. This should actually be Fahrenheit. Alright, that should be Fahrenheit, or we can make it 15 million degrees Celsius. Alright, we'll discuss that again tomorrow, Wednesday. During nuclear fusion inside the sun, helium combines to form hydrogen. This is definitely false. A photon may travel through the radiative zone in just a few seconds. That is definitely false. Try 50 million years. 50 million years, guys. That's a long time. Material that rises through the convective zone cools at the sun's surface. That's going to be true. Right? Because it's actually going to be pushing that heat out so that it can collect out in the corona. The photosphere has a grainy appearance because it has several different colors. This is going to be true, and remember that color equals temperature. Alright, if you're still confused on that, stop by and see me Wednesday morning. The sun's corona has a much cooler temperature than its photosphere. That's definitely going to be false. The corona, right, we're talking corona 2 to 5 mil, as in million, whereas photosphere we're talking 6 to 7,000. So I'm going to shorthand 1,000 as K. The sun's atmosphere consists of 3 layers. I went with false. Not 3, it should have 2. The photosphere is the visible surface. Then you have the chromosphere and the corona as the 2 layers of its atmosphere. Sunspots occur where a loop of the sun's magnetic field breaks through the solar surface. This is true. Sunspots usually occur in cycles that repeat every 21 years. That's false, right? It's actually every 11 years.
Alright guys, so that was actually last year's video. So hopefully you guys realize you actually have a test on Tuesday. We will finish reviewing on Monday. Hope you guys all enjoy your weekend. To the teacher that's in the room, thank you very much. Sorry you had to sit through that. And I hope you all have a great Veterans Day. Check your backpack for the rest of your homework. Bye-bye.